Greetings all. I myself Sudipta Chaki is going to present our research work titled as A Framework of an Obstacle Avoidance Robot for the Visually Impaired People. Our paper ID is 324. Now I'm going to discuss our research paper presentation slide in brief. So these are the contents I'm going to discuss in brief in my next session. The primary objective or goals of our project is to accommodate our robot with an obstacle avoidance algorithm so that if any obstacle is detected within a certain range, the robot can automatically move either right or left depending on the intensity values of the images. The robot collects its surrounding images and is sent to the Raspberry Pi unit to analyze them to detect any obstacle coming towards. The overall contribution of this paper are depicted below. We developed a prototype of obstacle avoidance robot that is capable of providing a safe passage by avoiding obstacles in its way. Our prototype robot is integrated with an obstacle avoidance algorithm that performs better with lower time complexity. And the last contribution of this paper is it can be beneficial for the visually impaired people if we integrate our robot with a smart game. Some recent advancement has been already done in this field. Now I'm going to focus to notably research. A recent advancement for the object avoidance robot is proposed in one by the authors where they built a prototype of ultrasonic sensor-based electronic aid to avoid obstacles while moving in the environment. But due to the large size of this prototype device, it's not suitable for lightweight version-less robots. The bug algorithms proposed by the authors into the potential field techniques and the vector field histogram approach are applied. Now I am going to discuss our proposed framework that is shown in this figure. First of all, the device will start up when the power will be given to the processor unit and to the Microsoft Kinect camera. After booting up the Raspberry Pi, which is used as the processing device, a program inside the Raspberry Pi will automatically run. The task is done by writing a bash script, and a bash script is a text that contains a series of commands. The camera will sense the surrounding environment. Based on the position of the obstacle, the processor will send signals to the motor driver. Depending on the signal of the motor driver, it will turn the wheels attached to the device. A battery of 12 volt is used to supply power to the Raspberry Pi unit. The voltage regulator regulates the voltage level, and the Raspberry Pi operates on 5 voltage. For providing it or controlling it, the Kinect is powered using the booster module. So we have discussed our principles of our framework in my previous slide. Now I'm moving to our next slide to discuss the object detection phase. The formation generation layer uses the position of the suspected impediments to decide where the robot should travel in order to produce a specific configuration. The terms target and the place are used in this paper to refer an obstacle-free path and point where the robot should travel based on the position of the abstraction. The generalized format of the formation matrix is depicted in equation 1. The robot measures the distance d from the upcoming obstacles in its way in order to move to a certain direction. That means either left or right, depending on the condition based from the flag bits. The assessment of the distance measurement is shown in equation 2. An outline of distance measurement of our robot board is shown in figure A, and the location and target that are calculated using the distance cost table are shown in figure B. So this is our proposed object avoidance algorithm. Avoid the obstacle, it relies on the flag bit condition. First of all, if the flag bit value is between 0 and 2, it means the left side of the obstacle is safer. So move safe signal is given by the processor unit. If the flag bit value is between 1 and 3, it means the front side of the camera obstacle free. So move forward signal is given by the processor unit. And last of all, if the flag bit value is between 2 to 4, it means that the right side of the user is obstacle free. So the signal move right is given from the processor unit. So we have performed several experimental setup to test the performance level of our proposed framework. And for the safe state, in this phase, the objects that are approaching towards the robots are defined as obstacles based on the intensity values. The intensity values of this scenario is depicted in figure B. Uh, Based on the intensity values and the flight bit condition and the measured distance between the obstacle and the robot board, the Kinect device captured the image, and after analyzing that analysis done from the processor unit, Raspberry Pi unit, the system detects the object is at safe distance and generates a soft signal for the robot to move forward. And this is one of our safest step. In the next state, it depicts a nearer state. When the obstacle is closer than the safe distance, the robot rotates in a certain direction based on the intensity levels shown in figure B. The intensity levels got darker than the previous safe state as the obstacle is nearer to our robot. In the collision state, when the object is at collision state, the nearest pixel of the obstacle got even very darker, shown in figure B. And this indicates that a collision might happen if the robot continues to go in the same direction. To avoid this collision, the robot sends a collision alert signal and thus perform a collision state removing stage. We have performed or made a comparative study in this table 1 based on 4 parameters, and we have got satisfactory result in terms of efficiency, performance, and complexity level in respective to the current advancement in this field. The notation of this table is shown in the below. So here is our last part, conclusion and the future works. Our primary target was to develop a lightweight obstacle avoidance robot that would pave the way for the blind people. And this framework largely relies on the Microsoft Kinect camera to sense the environment accurately and to analyze the captured images with its obstacle avoidance algorithm. By using Raspberry Pi unit incorporated with the Microsoft Kinect, we have improved the overall system performance. In the future, we want to integrate our robot with a smart game so that the task of sensing the surroundings becomes more reliable so that it can improve the user-friendly experience level for the blind people. So thank you very much for your patience. And if any question arises, feel free to ask me. Thank you all.